So sample problem 510 is kind of a very standard way that you'll see in the laboratory to measure gas that might be evolved in a chemical reaction. So what you'll have here, and this is again very similar to the setup you have in lab, you have a chemical reaction that's going on in what we call a closed system. So you might have a test tube that the reaction's occurring in. You'll have a tube that allows you to essentially take what was a filled water container and evacuate the water as the gas bubbles in. Now, you guys have a burette that you'll use in lab, so that will actually allow you to accurately measure the volume of water that you displace, which is correlated to the volume of gas that's evolved. So for this specific chemical reaction here, they say acetylene, again an important fuel in welding, is produced when calcium carbide, that's a solid, reacts with water. So what we have in this test tube here is you're going to have calcium carbide that you'll mix with water. So you might have two different test tubes that when you turn them over, they mix with one another. You're going to evolve acetylene gas and you'll make aqueous calcium hydroxide. But as that gas is evolved and it bubbles out, you'll collect that gas over water. So this is called a collection of gas over water. And you'll see why that's important here in a minute as we kind of collect all our variables together. So for a sample of acetylene that we collect over water, the total gas pressure adjusted to the barometric pressure is 738 torr. The volume of gas that we collect is 523 milliliters. At the temperature of the gas, which is 23 degrees, we just measure the temperature of the room that we're doing this reaction in, the vapor pressure of water is 21 torr. So the question is, how many grams of acetylene are collected? So let's kind of put down our pieces of information that we know and where we want to go here so we can start kind of walking between different things here. We'd like to know how many grams of acetylene gas are collected. So information that we know they tell us that the total pressure of the gas is equal to 738 torr, that the volume of the gas that we collect is 523 milliliters, the temperature that we collect this gas at is 23 degrees Celsius, and then they also tell us something. They tell us that the water vapor pressure at 23 degrees is equal to 21 torr. Until you've done a few problems like this, you might not know what to do with this. But remember, when we're collecting a gas over water, the pressure of that gas that we measure in terms of the atmospheric pressure is a combination. So pressure total is equal to the partial pressure of our acetylene gas plus the pressure of water vapor, since we're collecting that gas over water. So if we want to figure out what the partial pressure just is of acetylene, so the partial pressure of C2H2, that's going to be equal to the total pressure minus the contribution from water. So really we can take the difference of these two to get the partial pressure of just the gas that we're interested in, which is 717 torr. Well, this chapter is all about PV equals nRT, so that's again another piece of information we know. And if we're given the pressure and the volume and then the temperature of a gas, knowing the gas constant, we can figure out the number of moles of gas that we have. So the number of moles of acetylene gas can be figured out if we know the pressure of acetylene. We just figured that out. The volume of acetylene, we have that. The temperature of acetylene gas, we do know that as well. And again, using the R gas constant, we can figure out the moles of acetylene. Well, gee, the problem is asking us to figure out the grams of acetylene. Well, good thing we know a way to walk between the quantity of something in terms of moles and grams. We can use the molar mass for that. So now we basically set up our problem. We're going to solve for the number of moles of gas using these pieces of information, and then we're going to use the molar mass to convert it to grams. Now keep in mind, we know based on the R gas constant that we need to have pressure and atmosphere. We don't have pressure and atmosphere right now. So let's go ahead and we can convert pressure to atmosphere by dividing by 760, because 1 atmosphere is 760 torr. So we're going to go ahead then and get 0.943 atmosphere. We need to have volume in liters. So doing a mental math here, 0.523 liters is 523 milliliters. Temperature always needs to be in Kelvin, so this is going to be 296 Kelvin. Now we're ready to solve this equation, and we get the pressure times the volume divided by the temperature times our R value, 0.08206 liter atmosphere per mole Kelvin. That gives us 0.020304 moles of acetylene gas. Again, if we take that and we multiply, I'm running a little bit out of room here, 1 mole of acetylene gas is 26.04 grams. We end up with our final answer of 0.529 grams of acetylene gas. Pretty straightforward, and again, once you do these kinds of problems, you realize that's why they're giving me the water pressure, or the vapor pressure of water, because when I'm collecting a gas over water, the pressure of just the gas is the total pressure minus that vapor pressure. Again, this problem could have been made a little bit easier if information had been given in the right units that we needed, so we needed to do a little bit more work to get those in the right units. But other than that, pretty much a pretty straightforward problem.